When designing a bike at Ridley, our primary goal is always the same: to build the best race bike in the world. The concept of each and every Ridley design originates from the same precept. Cyclists from all abilities and backgrounds, be they amateurs, professionals or club riders, all want the same thing: to ride on the best and fastest bikes available. Our development process is both simple and efficient. We start a wish list with clear goals to be implemented in our range. Form follows function. Before we put our frames into production, our comprehensive list is converted to 3D computer designs, on which we carry out extensive testing. The results of these varied tests has formed the basis of some of the greatest innovation. The integrated seat tube with the corresponding seat post clamp provides extra stiffness and an improved aerodynamic function. Oversized head tubes were introduced by Ridley in 2001 on the Damocles, and they're now the norm in the bike industry. The vibrations on the fork are significantly reduced because the forces developed in the head tube are spread over the larger surface of the oversized bearing. This improves handling and provides extra stiffness on the fork. In addition to physical wind tunnel testing, we work heavily with 3D simulation modeling, which allows us to cover all variables. The prototypes developed from these designs are originally stress tested on the computer. Once these model tests are satisfactory, we move the testing process to the field and our Ridley professional riders. Our Pro Team riders are constantly testing our bikes and provide continuous, invaluable feedback. We take this feedback very seriously and implement much of it into further and continued development of the bikes. The models available to buy by the public are direct derivatives of those tried and tested by the professional riders. The technology becomes available to the public with no modifications or shortcuts, only 6 months after the race teams have been issued with it. For some prototypes, we develop plastic models using 3D printers. These mock-ups allow us to test both the form and function of the technology before committing the designs to production. These prototypes are continuously fine-tuned until every detail has met with our high standards. The choice of the different carbon fibers is crucial. Our carbon frames require more than 100 different carbon fiber materials. Every layer of carbon requires the exact strength and stiffness, with different layups in different frame locations. We use the knowledge and experience of our engineers to determine the correct layup schedule of the carbon layers in order to obtain the best results. Our ton rating is very simple. It simply refers to the strength rating or tensile modulus of the carbon. The higher the rating, the stronger the carbon, thus less material is required. Our ton ratings are 60, 50, 40, 30 and 24-ton high modulus carbon fiber. After the development phase, we produce molds for the production of raw carbon frames. Once the molds are fully developed, frames can be produced in whatever quantity is dictated by the demands of the market. The raw frames are quality checked thoroughly, with special attention to our carbon frames, before they're sanded, cleaned and prepped by hand. The frames then enter the production line for painting and final preparation. Every colour and design detail that you see on the finished frame will have been carefully applied by hand, one layer at a time. These transfers are applied to a previously prepared frame, which has been sanded and cleaned. At this stage, the actual painting begins. At Ridley, we draw on our heritage and roots as master frame painters to deliver the highest quality paint finish. The painting process is applied in layers, beginning first with a clear coating, which acts as a primary bonding layer to the frame. This layer is then left to dry. Once the base layer is dry, subsequent colour layers are applied in reverse order to what's visible on the finished frame. After each stage of painting, the frame is once again left to dry before adding the next layer. Once the paint is dry, the stencil transfer layers are removed to reveal the nearly completed frame. This is a delicate task, which often involves precisely removing tiny details of the transfer layers. The frame is then cleaned and the paint finish is quality checked before having a final clear coat lacquer applied to the entire frame to complete the process. Once the clear coat has dried, the frame is baked gently in an oven. At the end of the painting process, frames are quality checked again, milled and prepared for either full bike assembly or shipping as a bare frame.
Stay tuned for more Orange Peel TV.